Good afternoon, everyone. My name is Sam Weaver. I'm the CEO and a co-founder of Cool Energy, which is based in Boulder, Colorado, and we are working to solve the problem that you see on the screens there. So we've created a device based on the Stirling cycle engine that performs waste heat recovery on heat streams that are otherwise not practical to recover from, either because they're too cool or because they're not high enough temperature. We've built 5 generations of these engines, and I want to show you more about them. So the device you see there on the screen is called an afterburner. It's used to destroy pollutants from chemical manufacturing as well as food processing, and it destroys the VOCs by raising the temperature to about 1,000 degrees Fahrenheit. We can put a heat exchanger in that afterburner stack and recover enough energy to make 25 kilowatts of clean electricity behind the meter. So you can see this 5th gen engine that we have is higher efficiency than most of the competing technologies, which are based on organic Rankine cycle technology. We recently had 4 employees from the US Army come out, civilian employees, and confirm our measuring system and our results. So in addition to recovering from pollution control equipment, we can also recover from the exhaust stack of internal combustion engines, everything from gensets in remote locations to ship engines are all possible applications for this. There's our 4th gen engine recovering the exhaust heat from a CAT diesel genset and boosting the output by 7%. So the genset market is bigger than you would think, and 40% of the units that are sold that are natural gas or diesel are base load. And that's important to us because the more often that we're producing value, the quicker the payback time is for the customer. And so you can see essentially that same thing there on the chart. It's the number of hours per year that the process runs that determines how quick the payback will be. That also combined with whatever the electricity rate is in the region. So there's the 5 generations of engines that we've built. You can see in the upper right, installing one of them at Schneider Electric's research headquarters in Grenoble. The upper left, we put 9,000 hours on a 24/7 test stand, and now we've just started testing our 25 kW size. We just completed this year a joint venture formation and a licensing deal with our manufacturing partner in China. And we expect that to go well. We are sending a pilot over there as a fundraising demonstration, and it's based in Nanjing, and their quotes look extremely attractive. The team, my father and myself, started Cool Energy. Bill Gross invested in 2011 through his company Idea Lab. Brian Newell's been with us doing the mechanical engineering for the whole time we've been in business. And so this is a platform technology. It's not just focused on heat recovery. It can also be deployed in concentrating solar power or military applications. This is an example of Edison Microgrids, which is building a pilot in China, and it will use our engines as the power production block for that, and it incorporates thermal storage as opposed to electrical storage. So we've got 9 patents issued on the technology and 1 more pending that we're taking international right now. We've been funded about $1 million a year to date, and last year that is all going to be based on revenue. So we're looking for capital to scale and partners to work with. Thank you for your time.